They are saying show that this 2 times 5 raised n minus 5 raised n plus 1 plus 5 raised n plus 2. They are saying show that this thing is even for all positive values of n. Okay. Show that this thing is even for all positive integer values of n. They want us to show that this thing here is even for all positive integers of n. So for all positive integers of n. That's what they want us to do. For all n is a positive integer. You know what integers are, right? Integers are these numbers here. Is 0, minus 1 and 1, minus 2 and 2, minus 3 and 3, and so on. These are the integers. Or some people write them like this. They say, okay, they are coming from the smallest to minus 2, minus 1, 0, 1, and 2, and so on. This is how some people write them. So these are your integers. So they are saying for all your integers that are positive, which is from 1 going to that side, this is even. That's what they are telling you. They're saying this thing is even for all. So this thing, for all, this thing here is even for all these things. It's even. So it is even. For all n is a positive integer. So they're saying show this. So how do you show this? The first thing that you should understand is the term even. What do they mean by even? So you must know the definition of an even number. Once you know the definition of an even number, you can easily show that this thing is even for all n is a positive integer. So what is an even number? You know even numbers. Examples. Let's say the examples. Look at examples. The ones that are common examples of even numbers. You can say 2, 4, 6, minus 8, 10, 20, whatever, or minus 6, and so on. You can list infinitely many even numbers, right? So you know them that these are even numbers. These are the examples of even numbers. But what is an even number? Right? So an even number is any number that can be written as an even number is any number that can be written as an integer times 2. That's the definition of an even number. So it is any number that can be written as an integer times 2, or it can be expressed in the form 2 times k, where k is an integer. So an even number is any number that can be written as an integer multiplied by 2, which means an even number is any number that can be written as an integer multiplied by 2. Look at this one, at 2 for example here. So 2 is even because 2 is equal to 2 times 1. This is, which is 2 can be expressed as an integer times 2. 4 is also even because it can be written as 2 times 2, which means it can also be expressed as an integer times 2. That's the definition of an integer. Take 5, take 10. 10 is also even because it can be written as a product of an integer and 2, which means 2 times 5, this is our integer in this case, take minus 6 is equal to 2 times minus 3, and this is an integer. So this is what an even number is. So now, if you want to show that this thing is even for all, positive integers of n, then you must show that it can be written as 2 times an integer. That's what you need to do. That's what you need to do. You must show that this thing can be written as an integer times 2, then that it is even. That's what you should be aiming for. Let's do that. So I'm cleaning these examples of mine. Yeah. So I'm rewriting this. 2 times 5 raised n minus 5 raised n plus 1 plus 5 raised n plus 2, right? So, okay, there's nothing much you can do here. This is 2 times 5 raised n minus 5 raised n, right, times 5 raised 1. Because you know that if you have n plus 1 there, so these, before it gets here, you are multiplying 5 and 1. You multiply 5 raised n and 5 raised 1. Then you took one base and added the exponent. You know for this from exponential simplification and stuff. So this is how this looked like before it got here. And this one is here. You can say the same thing about this one. So this was 5 raised n times 5 raised 2. Right? So when you're here, you can take out our common factor, which is 5 raised n. So 5 raised n is our common factor. It's out here. So here we're left with 2 times 1 here. Minus 5 raised n. 1 here times 5 raised 1. Plus 1 here, because this has been taken out as common factor, times 5 raised 2. So you can punch this straight from your calculator. So it's 2 minus 5, which is minus 3, plus 25, which is, this is 22. So we have 5 raised n times 22, right? So 22, so this is the same as equal to 5 raised n into 11 times 2, right? And you can say, okay, you can group these two together and say this is 5 raised n times 11, right, times 2. So you know that the product of real numbers is associative. So you if you multiply a, so a and b, a, or bracket of a times b times c is the same as bracket of a times the bracket of a of b times c. So which means if you are working with real numbers, if your a, b, and c are real numbers, right, the a times b times c is equal to a times b times c. So the product of terms on real numbers is associative. So I just applied that there. Same thing. And it's also, yeah, so that's how you get here. And also you know that you don't have to do this, but you also know that it is commutative, which means the order does not really matter. So we can just say this is the same as, doesn't make too much difference. Doesn't make difference at all. 5 raised n times 11. So what you can tell here is that 5 raised n is an integer if n is greater than 0, or if n is your positive integer, right? So if this is always a positive integer, this would always be an integer as well. Because if it's 1, you have 5. If you have 2 here, it's 25. If you have 3, it's 125. If you have 4, you have whatever that is there. So this will always be an integer. 4 will always be an integer. 4 n is a positive integer. But we're told that that is the case, right? And here, this part here is an integer, and this one is 2. And we said an integer is any number that can be written as an integer times 2. So we have an integer here, because this is an integer and this is an integer. So the product of those integers is an integer. And this one here is 2. So this is even because it can be written as an integer times 2. That's what this is. That's how you do it.